Watching this video will be talking about finding linear relationships. In this video, we're going to be reviewing what linear relationships are and how to find them using data. So, a linear relationship, if you recall from the previous lesson, is a relationship that creates a straight line on a graph. So if you graph information and you create a straight line, that's a linear relationship. Non-linear relationships are not straight, they're curved, right? So you might end up something like this, right? Even though it's kind of straight, that bump, it's not linear. It has to form a straight line. So how can I tell if my data, this table, follows a linear relationship? Well, you could graph it, and you could make a straight line, right? If I graph this data and I make a straight line, then I know it's linear. But sometimes making a graph can be hard, or there might be too much information to make a graph. So instead, we find the pattern. If your data is to be linear, your y values must change by the same amount each time your x values change by 1. So every time your x goes up by 1, your y values must change by the same amount, right? So x changes by 1. Well, this changed by 6, right? Well, this changed by 1. Well, then this changed by 6. And so you can probably start predicting that each one is going up by 6. So every time the x value changed by 1, the y value went up by 6. So because they changed by the same amount, because this changed by the same amount, this proves that it's linear because it changed by the same amount. Now you have to be careful though, right? The x values need to change consistently too, right? If this went up by 6 when this went up by 4, it's not matching the pattern. So you have to make sure the pattern stays consistent. So how can we show a linear relationship through math? Well, we can use an expression. This expression will show how y and x are related. So let's take a look at this table. How are x and y related? Right? You may notice that y is always 3 times whatever x is, right? 1 times 3, oh, that's the y. 2 times, so an x here is 2. 2 times 3, 6. 3 times 3, 9. 4 times 3, 12. 5 times 3, 15. So you could just say y is always 3 times x. X being whatever's here, and y being whatever's here. Right? We're not using hard numbers because this is showing me that for whatever number, any number here, it could be any number here, y is going to be 3 times that. So pick any number. Okay, let's pick 6. Okay, well, following this pattern of going up by 3, y equals, okay, so we have 3 times 6. 3 times 6, 18. Oh, they match, right? So this expression shows this pattern. And so that's what you would write. If I said show the expression that proves that this table is linear, you would say this for this specific table. Different tables will have different expressions. So let's practice some. Pause the video and see if you can find which ones are linear, which ones are not linear, and if they are linear, give me their expression. So pause it now. Okay, so hopefully you paused it because I'm going to solve them. So as x goes up by 1, y went up by 3. Went up by 1, went up by 3. Went up by 1, went up by 3. So these going up staying consistent, and this going up is also consistent. So you can say it's linear because it's staying the same. It's going up by the same amount. The change is the same, right? It's going up by 3 each time. And so you could look at it and say, okay, well, this data shows me that y is always 3 times x, right? 1 times 3, 3, 2 times 3, 6. So you could use the same data table here, the same expression for the previous data table for this data table. Y equals 3x, right? 4, if x is 4, 3 times 4 is 12, right? So we proved it's linear, and we got the expression. Let's try this one. We start at 2. We go 2 to 3 to 4 to 5 to 6. We're going up by 1. Cool. Well, every time x goes up by 1, y is going up by 7. Going up by 7. Going up by 7. Going up by 7. Right? And so this is staying, the change in this is staying consistent, and the change here, more importantly, is staying consistent. And so what would the expression be? Y equals, and now you may have noticed that in this one, this changed by 3, so the expression was y equals 3x. This changed by 3, so the expression was 3x. What do you think the expression will be for this one? 7x, right? And you can prove that. Pick any number. Let's pick 4. Okay, well, y equals 7. Now in this case, x is 4, so times 4. Y equals 28. And that proves it, right? They match. It matches the pattern. So our expression works. And so this is an example of a question where as long as you check your answer, you can always get the right answer. You may have also noticed that the amount this changes by is the number that appears here. The amount this changes by is the number that appears here. That's a bit of a cheat, isn't it? So let's move on to this one. X, 2, 3, 4, 5, good, it's going up by 1. Here, we went up by 4. Here, we went up by 4. 12 to 17, here, we went up by 5, and here, we went up by 4. So all of these went up by 4 except for this one. So is it linear? No. If this is changing by 1, right, this is going up by 1 each time, and these don't stay the same, these changes don't stay the same, it's not linear. And if you were to graph this, you'd end up with something like this, right? You'd end up with something like that. And so it wouldn't be linear. And so this one wouldn't have an expression, or you couldn't call it linear. So what if your x values didn't go up by 1? Every other time I showed you it went up by 1. It went up by 1. In this case, it didn't work, but it went up by 1. What if your x values are not going up by 1? Is the data linear? Take a look at this chart, pause the video and see, and try and estimate or determine whether or not this data table is linear. Okay, hopefully you pause the video. So as x is changing here, x is changing by 2 every time, right? By 2. By 2. By 2, right? Okay, well, how much is the y changing by? This is changing by 8. This is changing by 8. Changing by 8. Changing by 8. Is it linear? It's not going up by 1, but is it linear? Well, yeah. The data is linear because as the x changes, the y is still changing by the same amount. You can see I'm putting emphasis on the y, right? The y needs to change consistently. Every time x changes by 2, well, the y changes by 8. Right? Every time the x changes by 2, the y changes by 8. So what expression can we use to show this relationship? What do you notice about the x and y? What could you use? Y equals what? Well, in this case, the y equals 4x. How did I get that? Well, look at 2 and 8. Well, how do I turn 2 into 8? Well, times 4, right? Times 4. That's 8. Oh, 4? Well, times 4. Oh, 16. 6, 4, 24. Times 4, 32. Times 4, 40. It works. Whatever y is, whatever y is, it's 4 times x. So you could say y equals 4x, or 4 times x. Right? Okay, let's make this just a little bit harder, if it's not hard enough already. What would it be if x was 11? Instead, I went up by 1. Remember, I proved that this pattern is linear following this pattern. What should 11 be then? Okay, well, the clever ones might have realized that this one is 44, right? Because the pattern is y equals 4 times x. Well, what's x? 11. So y equals 4 times 11, 44. But this changed by 4. This was changing by 8. But remember, this changes by 8 when this changes by 2. But this only went up by 1, which is half the amount 2 is, right? So if this is only going up by half the amount, then this should only go up by half the amount, which went up by 4, which is half of 8. Now, there's another way to find the number for the expression, and I'm going to show you. If the x values are changing by more than 1, then you need to divide the change in y by the change in x. So, y is changing by 8. X is changing by 2. Right? So the change in y is 8, positive 8, and the change in x is positive 2. Okay, well, you divide the change in y by the change in x. So 8 divided by 2 is 4. So our expression will be y equals 4x. And that's what our expression will be. So hopefully that makes sense, right? You take the change in y, divide it by the change in x, and that'll tell you how much the y is multiplied, how much the x is multiplied by to get the y. It shows you the relationship between x and y. So try these questions on your own and find the expression for each table. So pause the video now. All right, so hopefully you paused the video. So x, well, this is going up by 3. This is going up by 3. This is going up by 3. Cool. So it's staying constant here. This is going up by 15. This is going up by 15. This is going up by 15. And this is going up by 15. Okay, so now we know that it's linear, right? Because as this is changing by the same amount, right? Every time this goes up by 3, this goes up by 15. Okay. Well, what would the expression be? Y equals what? Well, if we go back to the previous slide, you take the change in y and you divide it by the change in x. Okay. Well, the change in y is 15. The change in x is 3. So I could go 15 divided by 3, right, which would give me 5. So I take that 5 and I put that there. Y equals 5x. Am I right? Well, let's test it. Let's pick any number. Let's take 6. Let's take 6, okay? Y equals, well, 5 times whatever x is. In this case, it's 6 now. So 5 times 6, y equals 30. And so this is a way in which you can check your answer. If you get an expression and it doesn't match up to anything on the table, then you did it wrong. But if you get an expression, you pick 1 or 2 things on the table and you plop it into your x value and you get the same number on the chart, you did it right. Let's say I made a mistake. let's say instead of 5x, I got y equals 4x. Sure, 4x. Okay, well, if I picked 6 again, y equals 4 times 6. Well, 4 times 6 is 24, right? Is 24 matching here? No, I did it wrong. So this is a way in which you can check your own answers and make sure you got the right numbers. Let's try this one. 3 goes to 5, 5 to 7, 7 to 9, 9 to 11. Okay, so I went up by 2, went up by 2, 2, 2, and 2. Okay, well, every time x is going up by 2, y is changing by 4, 4, 4, and 4. So what would the expression be? Y equals, right, what would the expression be? Okay, well, I take the change in y, and I divide it by the change in x. So what is my change in y? 4 divided by my change in x. 2. Well, that's 2. So the expression should be 2x. And I can check my answer. I'll pick any number at random. 7. Okay, well, y equals 2 times 7. 2 times 7 is 14, so y equals 14. Does that match? Yeah, it matches. So I did it right. All right, let's check this one. 0, 0, okay. 0 goes up by 4, right? And I keep going up by 4. Well, this goes up by 12, which then goes up by 12, which goes up by 12, which goes up by 12. So as x changes by 4, y goes up by 12. Okay, what would the expression be? Well, the change in y divided by the change in x. 12 divided by 4 is 3, so y should be 3x. And you can check that. Pick any number. Let's say 8. Okay, y equals 3 times 8. So instead of x, I have 8 because 8 is my x now. Y equals 24. And it matches. So I did it right. So the expression is y equals 3x. I highly recommend doing these questions. They will enforce the idea and the pattern recognition for linear algebra. I know it's a lot of questions, but this is a hard topic, so I highly recommend you do these questions. All right? Hopefully you found this useful, and I'll see you next lesson.